ever to give credit. Okay, I was part of a committee with some professors at the Sloan School and stuff when I was in, it was LFM before LGO, to look at distance education. And John Little called it the Do Something Committee. We were actually going to do something rather than just be a committee. And so turns out General Motors wanted my welding course, and so we decided to let General Motors pay the tuition for 20 students, and we would take that money. The Institute said, okay, we'll take that money and we'll videotape it, okay? And I found, wow, it turns out I learned that semester, it's really good to videotape your class, because if the students miss class, even the students on campus, they can watch the movie, right? And it also turns out that, although I think I've only done this twice in the last 25 years, I can show a movie when I'm not here, okay? Which I did yesterday. It's probably the second time. There are some complications this semester. Dr. Belmar was supposed to lecture today. I was supposed to get back from Atlanta and actually get some sleep. I actually slept for an hour and 45 minutes this morning because the plane was late. But in any case, see, I'm rambling. In any case, he was going to lecture, but he had a problem and wasn't able to do that. So he'll be lecturing tomorrow. I'll be lecturing on Monday. I cannot lecture on Tuesday because I have jury duty. And who knows if they're going to select me for jury duty. Probably not. They don't like people who had testify in court on a regular basis. They know too much about what the attorneys ask. So I don't expect I'll be selected, but I'm kind of blocking out next week. So in case if I do get selected, then we'll get that straightened out. So we have to be a little bit fluid. As you know, we meet every day and we finish up early. I expect we'll finish up first or second week in October, and student presentations will start sometime towards the end of October and be over by early November, okay? So I found the students actually do like it when I force them to front load this class. First of all, I find that once we get off daylight savings time, students don't want to come in when it's dark, okay? It's just, plus the term wears on. Plus it's nice to have one less course as all your other courses are gearing up at the end. And so students have actually said that in the evaluations. So I front load it. There's nothing you have to read. I did hand out some, or put on Stellar a bunch of things. One is, I'm kind of writing a book. I'm starting my 41st year on the faculty this month, or this summer. So a few years ago I started a book that I hope to finish and title it 50 Years at MIT, because I started at MIT as a freshman 48 years ago. And so this is something called Surviving at MIT Lessons Learned that I put together a couple of years ago, and several students have enjoyed that. I sometimes use this class, and I did for a whole semester, to try to figure out what the difference is between a scientist and an engineer. And we didn't cover this yesterday, right? Okay, I didn't think so. So I've always sort of wondered, what's the difference between a scientist and an engineer? And so there's 3 pages here of definitions, and my favorite is mine, one of mine. Science seeks to increase human knowledge. Engineering seeks to improve the human condition, okay? And it's sort of an attitude thing. Scientists feel like the world owes them a living and should provide them support to study anything they want because knowledge is wonderful. Even if it's about something that happened 13 billion years ago, the Big Bang or something, which, okay, maybe it has, but and then people say, well, science is what spins off new technology. That's bull, okay? Do you know why the transistor was developed? It wasn't basic research at Bell Labs. Anybody know why Bell Labs was looking for an electronic switch? All you mechanical engineers. AT&T in 1925 at Bell Labs, well, first of all, they had and this is actually sort of related to some stuff we'll talk about today. But AT&T, there's a book called, what's it called? The Idea Factory. There's actually two books. One's about MIT. It's written by a mechanical engineering graduate student, and he called this book MIT about his experience at MIT, The Idea Factory. There's another one about Bell Labs, and it's called The Idea Factory, and it talks about how Bell Labs became a public regulated monopoly in around, the Bell system became a public regulated monopoly, and that meant that they would get 6% profit on whatever they spent. Okay? So one of the things they could do is research. And they get 6% profit guaranteed. They just goes into the rate base, okay? And so everybody thinks, oh, wasn't it wonderful for AT&T to be so foresight and have so much foresight? And it had nothing to do with that. It had to do with the fact they would make 6% profit. The more money they spent, the more profit they would get. And it used to be called a blue chip in the old days because you knew your dividends would pay back about 6%. I mean, it was like a government bond because it was self-regulated and everybody had a telephone. Well, it turns out a lot of what we know about statistical process control and stuff was developed at Bell Labs in 1925, okay? They wrote the book originally on statistical process control and statistics in manufacturing and stuff because they had to make telephones. And they also were looking ahead because they could afford all these people to look ahead at 6% profit. And they basically said, what's the growth of the phone business? And they had switchboard operators, you know, the people sitting there moving plugs around and stuff. Those are all mechanical switches. They looked at the failure rates. Okay, there's something, I could have brought it in, called the Att Reliability Handbook or manual or something. And it has all the statistics for failure of mechanical switches and bearings and motors and electrical switches and stuff. Anyway, they were collecting this data and they looked at how many telephone calls were being made each year, and they could project in the future, and they realized that if they didn't come up with something other than a mechanical switch, which had a failure rate about 1 in every 10,000 hours, okay, they would have so many billions of switches that the whole phone system would come crashing to a halt because of the failures at that failure rate. I mean, you can just do the math, okay? And so they needed a more reliable switch. They were not doing basic research on the transistor. They were looking for an electronic switch that would be several orders of magnitude more reliable than a mechanical switch. Mechanical switches have friction and wear and stuff, and they fall apart after a while, okay? And they knew that, and they knew the whole system, if several decades hence, was not going to work unless they could come up with a switch. And so they were searching. It was actually applied research. It was not basic research. So whenever you hear you read these stories, oh, Bell Labs was so, why don't we have Bell Labs anymore? Why doesn't the industry pay for basic research? They weren't paying for basic research. They were spending money because they got 6% profit, okay? And they were doing applied research on some very important things, and they were looking out 40 and 50 years, whereas most industry only looks at, how many years does the industry look out? You're right, they use 5 months, actually, in some cases. But no, no, seriously, people say the next quarter, right? Okay. Yes, in terms of what they consider research, 5 years is probably a good number. What I had in my mind was actually something I don't know if I gave you a copy of this article I call Bringing New Materials to Market, an article I wrote on bringing new materials to market. And I pointed out no one ever has more than about 20 years, looking more than 20 years forward, because if you spend $1 on research today, you have to return $20 at 8% interest, which is kind of a small internal rate of return. You have to return $20 in 20 years. If you go out further than that, you're going to have to return $100 for every dollar invested today. And for that reason, we've had 20 years of oil reserves for the last 100 years. Because they go out and look for oil until they got 20 years worth, and no one goes and searches for oil anymore. The exploration goes down because you can't afford to invest the money now for something you're not going to get the payback until more than 20 years. Yes?
I don't know if I believe you that basic research doesn't give you technological breakthroughs.
Well, I didn't say basic research. I'm saying industry doesn't really do a lot of basic research. The government pays for basic research. I'm sorry, I'm not trying to say basic research doesn't lead to innovation. But, I mean, in my career, if I actually go and see why a company was doing something, and I mean, Bell Labs is the example people give of, oh, how much foresight did their managers have because they were doing basic research? I'm saying, that's bull. They were not doing basic research. They were looking at a problem. They knew they had a train wreck coming. And they were doing applied research to, now it turns out, it turned out to be pretty good basic research, okay? But they had an applied problem that they had to solve. And so industry doesn't just go out and spend money, okay?
For the betterment of human knowledge.
Right. They're not a bunch of scientists. They're actually more a bunch of engineers. And they're trying to improve the human condition, which means they're going to help make communications great and everything, okay? And communications have come a long way. I mean, I have a daughter who moved for her family for 3 months to Tonga this summer. And then the first day there, my granddaughter was climbing a tree and fell and broke her femur and Tonga doesn't have health care, so they had to fly her to Auckland, New Zealand to have her leg set. But Linda gets on the phone and calls me, and she's got her cell phone that she uses ordinarily in North Carolina, and she's calling me from Auckland, you know, and it's just a regular old phone call. I mean, you couldn't do that when I was your age, okay? So communications have certainly grown and developed, but most of what industry does is profit motivated, okay? The government, on the other hand, does fund research that could be 40, 50 years out because they're not looking for an internal rate of return per se, okay? That's kind of the point I think I was trying to make. I don't know what point I was trying to make. Anyway, I'll pass this. Anybody not sign up plus yesterday? Anyway, I won't pass it around. If you have it, then here, if you want to sign up. So you have to do this presentation and stuff. What are we laughing about? What?
Oh. I was sad because I was like, basic research is important. But you're right, like industry versus government spending is different.
It's very different. Yeah. Yep. So it's.
Luckily, I'm funded by the government.
Okay. Well. Whatever. I mean, there's nothing wrong with basic research. There's also nothing wrong with applied research. You need a spectrum, and that's the thing like throwing the technology over the wall and the death that occurs. I handed out a paper on the World Trade Center, which did I explain why I wrote this paper? Oh, okay. Well, so I wrote this paper because some editor of a journal asked Professor Joel Clark, about 3 weeks after the World Trade Center collapsed, if he would write an article. He said, well, why don't you ask Tom Eager? So he asked me, and I was so sick of reading newspaper articles about how the steel melted in the fire that I said, yes, any idiot who's ever been to a fire scene knows that steel doesn't melt in a regular old fire, okay? But all the editors of the newspapers and all the reporters, they didn't know that. So I decided to write a paper, and I wrote it. It's important, the rest of yesterday's presentation that you didn't get to see that you should watch, well, you can watch, it's up to you, is about communications. You should think about who you're writing the paper for. I mean, a graduate student just gave me a paper last week, and he said, and I edited, he wants me to be a co-author, and I edited made my comments to his draft. And he said, well, what did I think of it? I said, well, I don't know. What journal do you want to send it to? Because you should be writing for the journal you're going to send it to, okay? And most people don't do that. They just sort of write randomly. When I wrote that article, I was writing to a good high school science student. I wanted it to be understood by someone who knew a little bit, I mean, knew some of the words, And, I wrote this, 15 years ago. I haven't gotten an email about it since this morning. Okay, a guy wrote me and said, well, he found this paper about the World Trade Center, and he didn't know the difference between heat and temperature. Well, that's a fundamental concept in thermodynamics. One's an extensive quantity, one's an intensive quantity, and we don't have to go into thermodynamics, but I explained it in layperson's terms. So one of the things you have to learn to do as an engineer is you have to be able, you can do the best research in the world, but if you can't explain it to a layperson in the 15-second elevator talk, it'll never go anywhere. And so I give out this paper because I spent 3 hours writing this paper. Okay? That's the shortest time I've ever, out of several hundred papers I've written, shortest time of any paper I've ever written. By far, I've gotten more comments on this paper than all of my other papers combined. Why? Because it was written at a low enough level that lay people could understand it. It was about a topic that a lot of people were interested in. And the conspiracy theorists think I'm one of the great Satans of the world because they know the government actually planned the whole World Trade Center collapse and blah, blah, blah. But that's how many conspiracy theorists? 18% of Americans are conspiracy theorists on the World Trade Center. They believe. I have too. Believe me, I get it. The guy who sent me the email this morning was very polite, but I can sort of read between the lines. He's asking me about the explosions he finishes up asking me about the explosions in the lobby. Anyway, I never even heard of the explosions, and I've been listening to this stuff for 15 years. Anyway, so that's that paper. The paper that you probably should read out of this is called Socio Engineering. Before I get to that, the Japanese separate materials into two classes, and this class is supposed to be about structural materials, although sometimes we'll talk about functional materials. What's the difference? Well, if you're a mechanical engineer or a civil engineer, a structural material is something for which we are interested in the mechanical properties, which could be toughness, strength, creep, corrosion, whatever, aesthetic properties. Functional materials, on the other hand, have lots of different properties. They could be chemical properties, magnetic, electrical, optical. So you see these bullet points here are all different types of properties, whereas here, structural materials, we're really just focusing on mechanical properties. And there are a lot of different mechanical properties, and we're going to talk about which mechanical properties are most important. The thing is, structural materials are used in very large volumes, and here we have a small volume of the same Rubik's Cube. And so you hear a lot in the Wall Street Journal about functional materials. A few nanograms of such and such will change the world forever. Okay? I remember when MIT was talking about taking away the last freshman elective by requiring biology for all freshmen. And I was opposed to it, not because I was opposed to biology. I was opposed to getting rid of all the electives in the freshman year. I didn't think that was a good idea, okay? And the guy he was the associate dean of engineering, and we were sitting at dinner one time, and he says, well, Tom, biology is really important. I said, Herb, I know it's important, but, give them a choice. Don't take away all their electives in their freshman year. And he says, but Tom, everything's going to be biology in the future. Well, first of all, whenever you hear some absolute, like everything, not everything is going to be biology. I said, Herb, when you can give me a seed that I can plant by the side of a riverbed and a bridge grows across the river, I will believe that everything is biology. And he says, oh, you're a hard man. Okay, well, not everything is biology. Not everything is photo. Not everything is optical. Not everything is electrical. All these things are important, but they're used in very small volumes. We're going to talk about things that are used in very large volumes. We're also going to talk about the age of socio-engineering, and this is on Stellar. It's an article, actually it was a commencement address in 1993 at University of Colorado, or not a commencement address, but they had some engineering centennial celebration. Does anybody know who Norm Augustine is, other than he wrote a book called Augustine's Laws? Okay, he's a Princeton graduate, but he's a member of the MIT Corporation. He rose to become chairman of Lockheed Martin Corporation. He is a national spokesman for engineering. He became, I think he was he's head of the National Academy of Engineering. He was head of, I don't remember if he was head of the President's Council on Science and Technology. But he is a national spokesman. And if you actually get the original version, not this version of his book, which is sort of sanitized because he got into the management ranks, but when he wrote his first book, it has some great graphs, such as it shows the plot of the trend line for the cost of an airplane versus time. And it also shows the national budget, okay, and the Air Force budget. And it shows that in 2025, the Air Force will be able to buy one airplane with their budget, their entire budget, for the entire U.S. Air Force. And in 2070 or something, the U.S. government will be able to buy one airplane a year at the rate of increase of aircraft. Okay, now that's changed since he wrote this back in the 70s or 80s, because now we're getting people out of planes and having drones and stuff. But if you had followed that same trend line, the point was the slopes were different, and you were looking at the trends. And he was one of the few people who would essentially speak truth to power in his youth. And he's a great guy. I mean, I've met him a few times. He's on a lot of committees. He used to be on a lot of committees at MIT. But he said for every engineering action, there's a equal and opposite social reaction. And in fact, that's what I want to talk about today, externalities, which we'll talk about in a second. But he starts out in 2900 BC, and I don't remember why, that's structural age, and then he gets to the Industrial Revolution in the mid-1700s, which he called the mechanical age. Does anybody know why 1879 is a pretty specific date for the electrical age? You ever heard of George Westinghouse and Thomas Edison, General Electric, Westinghouse Electric? That was when we first had commercial electric power. Before that, it was just a scientific curiosity in a laboratory. But they actually did the engineering to make it freely available, mostly for lighting. And you find that lighting, street lighting, was a very big problem 150 years ago. Okay? The information age, and I don't remember why he came up with 1906 for the information age, but you can read the article. It's been a few years since I read it. And then in 1979, he called it the Socio Engineering Age. I think, is that the year of 3 Mile Island? I don't remember, but in any case. Basically, what he's saying is, anytime we want to do something in engineering, we have to worry about the social, economic, political consequences. We no longer are able to just engineer things in pure engineering. And in the past, when I was a student, we certainly didn't worry about these things. But now, a lot of students in school, the primary reason they want to be engineers is to help solve climate change or the energy crisis or you name it. But these are things that have social, political implications. Anybody taking an economics course? No one's ever taken an economics course? Okay. So what's an externality in economics? The economists define a term called an externality. Charlie Fine likes to talk about externalities over at the Sloan School. Okay, well, you don't have to guess too long. An externality in economics is a cost or benefit that affects a party who did not choose to incur that cost or benefit. So if your father smoked, my parents both smoked, we'd take a trip to go visit my grandparents 120 miles away, and all three of us in the back were also smoking, even though I was only 5 years old, because the car was full of smoke. Okay? That was a cost that my parents imposed on me until the Surgeon General told my father he could die of cancer. Died of a heart attack. Anyway, but we have all kinds of externalities, environmental externalities, but there are other externalities. Can anyone think of well, actually, I probably ought to give you an example of an externality, and I'll ask you later if you can think of your own externality. One externality that's political was something that happened with rare earths. Anybody heard about the rare earth problem? Externality? It happened about 5 years ago in 2011. China turns out, manufactures 97% of all the rare earths in the world. And this is a manufacturing plant. Pretty neat, huh? Is that where you want to work? Well, no one else really wants to work there either, but the Chinese are willing to put their people in those plants. And they didn't have 97% in the past, but they have 36% of all the rare earth reserves. Rare earths are not very rare. We've got 130 million tons of reserves in the world. That's more than 20 years supply at 31,000 tons shipped. They're not really rare. That's a bad name for them. They're actually very plentiful. I'll show you a plot of that later. But nonetheless, in 2010, they basically told Hitachi and Toshiba and all these people in Japan they were not going to ship rare earths to them. They could no longer make the electronics because you have to have rare earths to make the magnets that go in the electron. I mean, they're essential. And all of a sudden, the Japanese, I mean, this was economic war. And if you read the articles, you go and Google this if you want to study it. In fact, if you're thinking of a presentation, this would be a presentation topic. You can find all you want on the internet about the politics going on and how the Chinese said, oh, this had nothing to do with the fact we're fighting over the Spratly Islands or whatever it is, okay? But it had to do with political muscling, and they had developed a monopoly position because they were willing to eat the world's pollution on production of rare earths, of which they had a very high mineral resource, natural resource. The United States had their production facilities before China became opened up by Richard Nixon in the 70s, but the Chinese undersold us and all the American production facilities were closed. We had mines in California and stuff. We have reserves. I mean, they're not that rare, but we couldn't compete economically with the the Chinese prices. So when the Chinese had a monopoly, this is the oil embargo of 1972 all over again. You know, back then, the Saudis could produce a barrel of oil for $1. Right now, it costs the Saudis $5 to produce a barrel of oil. Okay? Now, the Canadians in the tar sands are number 2 behind Saudi Arabia in the amount of oil reserves. But it costs them $80 a barrel to produce a barrel of oil. Okay? So when you get down to a $40 barrel of oil, all those Alberta facilities are now deeply in the red and will be unless they can cut their costs dramatically, which they've been doing, or the price of oil comes back up. But that's what the Saudis did to try. They were tired of the Nigerians and all these other people, and the Nigerians, I think, have like a $10 a barrel price, okay, that they pump it out of the ground. So some people have cheap oil, some people have expensive oil. We've always had 20 years supply of oil, okay? We actually have more than 20 years supply. Actually, I think I may have it wrong. I think Venezuela is the third country. Saudi Arabia has the most oil, and I can't remember if Alberta, Canada is number 2, or Venezuela is number 2. But anyway, they're 1, 2, 3. And underneath the Orinoco River, there's 1 trillion tons of heavy oil. Only problem is you have to, dig it up. You can't pump it. Okay, it's heavy oil. It's like tar, like the Canadians. And it's hard to dig through all that river. The water keeps flowing in. It's a mess. So they don't really know how to get the Venezuelan stuff.
One other example is with the aerospace engines, and I think GE got slammed really hard because the trace elements that you use for the turbine, they changed to rhenium, and China had all the rhenium and cut supply, and it caused their engine production to almost double.
Right, and I didn't know that particular story about the rhenium, but actually I have some turbine type things. A lot of the alloys have 6% rhenium. Rhenium is one of the platinum group metals. Now it only goes for about $40 an ounce, and you can afford that in an aircraft engine. It's a little pricey. We don't like it, but it gives properties that we can't get other ways. Actually, we are we often develop ways around things. In fact, my next slide on this, so the Chinese basically held the Japanese with a gun to their head on the exports. But it turns out, I have looked at this for 40 years, and it only takes when someone does some sort of monopolistic thing like the Arab oil embargo or the rare earth problem, the Chinese will never have a stranglehold on rare earths for the next many years, because within 5 to 10 years, other people will come along and develop their own. When they see the power, the economic power of the disruption, they're going to protect themselves. After the oil embargo, well, at the time of the oil embargo in 1972, all the utility plants were firing oil in their boilers. They'd gotten rid of coal and stuff. And when they said you can't have any oil, they couldn't make electricity. Well, within 5 years, they had retooled their plants so they could flip a switch and go to coal or natural gas or oil. And so whichever one of those fuels was most cost effective, they spent the money to protect themselves against the extortion. Okay? And that happens all the time. So whether it's rhenium, whether it's oil, whether it's rare earths, people will get a monopolistic power and they will try to exercise it, but within 5 or 10 years, the rest of the world is going to adapt. Okay? I'll give you one more externality, this economic one. So one time, this is back mid to late 90s, I got a call because a woman was welding on a tank in the Oil City refinery of Pennzoil. So this is a picture postcard from the around 1910 or something of the Oil City, Pennsylvania refinery. It's just down the river from Titusville, where Edwin Drake discovered oil and drilled for it in 1856. So this was a 100-year-old refinery in 1996 or whenever I went to visit it. It was ancient, right there on the river. You can see it. And this is not the welding. They were welding on one of the tanks in the tank yard. And the first day I was there, you go out to the tank yard where this thing had blown up, and actually the woman got killed. She was thrown across the river by the explosion. But you go out to the tank yard, and it's gravel around the tanks, but you dig down 2 feet and you strike oil. They had been spilling oil so long there, for 80 years at that point, or 90 years, that, hey, there was oil everywhere. Okay, I'll show you some other pictures of that. And that night, I was in the hotel room thinking, how could Pennzoil, a huge corporation, run a plant like this? And then the next morning at breakfast, I figured it out. It's because they couldn't afford to close it. Because as soon as they closed it, it became a Superfund site, an environmental Superfund site. And they were going to, under the law, they were going to have to pay for the cleanup of the pollution they had been doing for 80 or 90 years. Now, since then, it has been closed. One of my former graduate students grew up right down there, near there, and he told me they have closed it eventually. It was uneconomical to run, but they were paying to run it because they couldn't afford to close it. Okay? That's an externality. Yes?
So I'm from Colorado, and there are a lot of old mines that are Superfunds. And
Yep.
the common strategy is for a mining company to be not an American company, to own the mine and then to go bankrupt so that they
Yep.
can't afford the.
And then it goes into the Superfund, which we all pay for as taxpayers.
So it seems like a good strategy if you want to get
Well,
some land off your hands.
when you see a lot of these consolidations of steel companies and things, the rules for what was pollution 50 years ago are not the same as the rules for pollution today. And that's what the next slide is. Oh, by the way, well, yeah, the next slide. Here's a picture of Oil City in 1864 after Edwin Drake in 1856, and they had barges full of barrels. And I was told, I couldn't find this on the web, that later they just floated it on the river. They had enough oil coming down from Titusville. They just, why put it in barrels and float it on barges? Let's just skim it off at the other end. Well, today, this is a picture of an oil slick. And in my town, in Belmont, where I live, about 15 years ago, they had an oil leak from one of the oil tanks at one of the elementary schools, and some high school student looks at Clay Pond and he sees an oil slick on the surface. Cost the town $2 million for the environmental cleanup. Well, Oil City back in 1900 wouldn't have had a problem. They would have loved to have seen water that clean, right? The rules have changed. Okay? The mining site, sludge ponds and stuff, that was perfectly legal when they did it. But now we change the law on these companies and say, oh, that wasn't a good idea, and we're going to make you pay for it. And some of these companies go bankrupt because of it. In fact, most of the steel companies in the United States did go bankrupt. U.S. Steel is the only one who's really been able to survive because of what they call legacy cost, the legacy cleanup cost. Yes?
So is it also an externality that the policy is negatively affecting the companies that at the time?
Well, yeah, I mean, you can call it a legislative externality. The company is told 50 years later you now have to pay for a cleanup that was legal when you did it. And that's, I mean, the company feels, the stockholders will feel like, well, it was legal when we did it, and now you're changing the rules. Well, yes, they are changing the rules. And I don't know what the right answer is here. Depends on where you come down as an environmentalist or a stockholder, right? What if you're an environmentalist and a stockholder? You're conflicted. Okay, anyway. Another externality is social conflict diamonds. Anyone know what conflict diamonds are? What are conflict diamonds?
Diamonds that are mined in areas that, they're mined by groups in areas that use child labor and other labor. They're pretty much in areas that are military or not necessarily military, but against the government, groups that are...
Right, they're rebel groups, like Angola and the Congo have been having civil war for 50 years. Actually, they just stopped their civil war in Angola about 5 or 10 years ago. And the Congo just stopped it after about 50 years, a few years ago. But the rebel groups were essentially forced labor of children and others to dig for diamonds, and they would take the diamonds and pay for their rebellion. What is ISIS doing? It's the same type of thing. We don't call it conflict diamonds, but they take antiquities and they either destroy them just out of spite, or they take them, sell them on the black market to raise money for their military operations. So conflict diamonds. Can you think of anybody have any ideas of externalities that from your experience? I still got more. I can fill up the hour. Another one is lead poisoning. Okay, this is a plot, and this will be on the web eventually, although I got to clean up. I had a problem with saving files in Dropbox, so I have 2 conflicted files. But anyway, this is on a log scale the tons of lead produced per year, and this is the Roman lead mines, which eventually wore out, but they were taking over 10,000 tons a year. The Romans were making lead pipes. Water pipes for their plumbing, right? Well, that wouldn't go over very well today. Lead poisoning, okay? And here's a little picture of all the places where we have lead at the house. Does anyone know why children eat lead paint? Small children eat lead paint? It's sweet. Yeah, it tastes good to them. Okay, I always wondered, what's this kid? None of my kids would ever sit there eating paint. But it turns out lead oxide is slightly sweet. Okay, and that's why they do it. Okay, mercury poisoning. Well, one of the problems we have is fluorescent lights. You find that lighting is an interesting topic if you wanted for a presentation. Okay, originally they had gas lights. And they produced gas different ways, and they transported gas for street lights, and they would hollow out logs to make the pipes. I've seen some of the logs they've dug up out of the city of Boston that were old gas pipes. Okay, they just drill out a log, bury it in the ground, stick some mud around it, and run gas down to have street lamps. Okay, and then Edison came along with light bulbs, incandescent light bulbs, tremendously inefficient. generate a lot of heat, but then fluorescent light came along. And if you take my welding class, I'll tell you how a fluorescent light works and how it differs from a welding arc. But they're all arcs in physics, if you're a physicist, okay? But in any case, one of the problems is there's a little bit of mercury in every one of these, because mercury is easily vaporized. You need a metal vapor in here to easily start the arc. After all, you've only got about 20,000 volts, okay, to start this arc. And you couldn't start it unless you vaporize some mercury first. It would take 1,000,000 volts to start that light, and that's not really safe to have 1,000,000 volts in the house, okay? It's not that safe to have 20,000 volts. But anyway, so mercury poisoning is another environmental externality. Another one that in this department you might hear about, because there's several faculty working on carbon-free metal production. Obviously, let's get rid of the CO2. Except for millennia, the very first metal oxide ores, were reduced supposedly thousands of years ago. They had a fire and they had some metal oxide ores in the reducing environment of the carbon monoxide in the fire, and they ended up getting some copper or tin or whatever, Bronze Age. Well, the reason for that, if you have to be a material scientist, is an Ellingham diagram for oxides. This is the free energy of the oxide versus temperature, and they all go up except for carbon and oxygen forming carbon monoxide. It goes negative. And so in theory, carbon monoxide can reduce every metal known to man, okay? Problem is, if you're producing billions of tons of a metal, you're producing a lot of CO2. And so people would like to get carbon-free metal production, and a number of faculty in this department have ways to do it with electricity, except where do you get the electricity? You're going to burn coal to get your electricity? Now you can use hydroelectric power, or you could use solar power, but if you start doing some of these calculations, you find that you got a problem of scale. Another is a military externality. Anyone ever heard of World War II? What was the reason for World War II? Why did the Japanese bomb Pearl Harbor? And we're doing the same politics today with North Korea, folks. Okay? And if they really have a bomb they can deliver, they might do the same thing the Japanese did. A preemptive strike. The Japanese had designs, they were murdering, slaughtering millions of people in Nanking, China, right? In the late 1930s. Their war machine, because they wanted to take over most of Asia, East Asia, they already had taken over Korea, and they were marching into China, and I think, did they estimate 30 million people were killed by the Chinese? I mean, you can talk about the Jewish Holocaust and Hitler, but the Japanese and the Chinese killed a lot more Chinese than Hitler ever killed in Europe, of Jews and others. Anyway, they were fueled with oil from Long Beach, California. The United States was supplying oil to Japan. We were also supplying scrap iron. They didn't have a huge steel industry back then. And we decided to stop this carnage in China by taking away the oil and steel from the Japanese. So if you take something away from somebody, what are they going to do? They're going to fight back. The Japanese, you can look at it from the Japanese point of view, they had no choice. If they were going to keep their military empire going, they had to have oil and gas, and so they had to get rid of this nuisance power, the United States. So they did a preemptive strike on Pearl Harbor, thinking that actually, what were they hoping to do at Pearl Harbor? They knocked out a lot of battleships, but what were they hoping to do that they didn't do? Anybody know that history? They were trying to get the aircraft carriers. They knew aircraft carriers. In fact, it was 4 Japanese aircraft carriers that steamed across the Pacific to attack Pearl Harbor. They were hoping to catch the American carriers, some of the American carriers at Pearl, because they knew if they wiped out some of the American carriers, the Americans could never fight back. But fortunately, we had like 10 battleships there, or 8 battleships or something. None of the all the carriers were out on the ocean, and they didn't get any of the carriers. And we only had 4 or 5 carriers, but anyway. And if you know the rest of the history of World War II, it was the carriers that actually helped win the war early on. Externalities can be cultural. Gold. Gold is something that has very little scientific intrinsic value. Very little. I mean, there are a few applications of gold. It's good for arthritis. They give you gold injections for arthritis. It's one of the only things that really works, okay? You haven't had gold injection? You don't have arthritis yet. Okay, well, I didn't know this until I was in my 20s. I rode to work with a guy in a carpool, and he was getting gold injections. But mostly it's ornamental, okay? And you can see we continue to mine. The growth in mining of gold has gone up dramatically over the last 150 years from 705 metric tons to 3,000, 4-fold increase in the amount of gold we produce. All the gold that's ever been mined, there was a National Geographic article, I couldn't find it on the web, but all the gold ever made would fit in a 100-foot cube, okay, from the beginning of the world. Where is half of the gold in the world located? And it's not Fort Knox, yes? Nope. It might be in the ground, but all the mined gold that's ever been mined since the beginning of the world, half of it is in one country, India. Ta-da! This is just an Indian bride, and she's got a fair amount of gold. This is a guy who was a real estate tycoon in India, and you know this story?
No, I just think
It is funny. I mean, he just liked gold. He really loved gold.
Yeah.
And so he had a gold shirt made for $250,000. And he became very famous. He wanted to become famous. You can see how proud he is of his gold. And about 3 weeks later, he was killed by some guys who attacked him. He wasn't wearing his gold shirt at the time, but he was murdered because he was just an arrogant guy, and some guys decided, I don't know. I don't know that that's really a very good topic for your presentation, but you can probably find a fair amount on it. It was only in the last year that happened. But it's a cultural thing in India, yes.
Do you have any positive externalities?
Do I have positive externalities?
I can't think of any.
Well, that would be a good presentation to try to think of a positive externality. No, externalities are a cost that's imposed. That's almost
A benefit that's imposed.
a benefit. Well, I'm sure there are some benefits, okay? A lot of social work is an externality. When people are altruistic and give of themselves, Mother Teresa, okay? You don't like that. Well, think of it, that's a good question. Usually we consider it a cost, and cost is usually considered a negative thing. Yeah.
In an economic sector, they said that research in the farm environment is externality because it increases the knowledge of all other research companies, and it also on a social aspect makes everyone more competitive and want to.
And that's a good example, and it comes along with your question before about basic research. And I said, well, the government funds basic research. That's a positive externality. Hopefully we get a payoff from that research that far exceeds the cost, right? There's a benefit that exceeds that would be a positive externality. So in general, I think the positives have to be, in my opinion, and this may be a religious type of opinion, when someone's trying to do something for someone else is when you can get a positive externality. If you're just trying to do something for yourself, make money, maximize profit for yourself, when you're looking inward, you're going to get negative externalities. When you look outward, you're going to get some positive externalities. But that's sort of a religious philosophy almost. But that's, we don't have to. We're certainly not going to talk about religion. Okay. Pardon me? Yes, okay. Yeah, you can call it philosophical. Regulatory. Okay, so I got pictures of solar panels and wind farms. Why is this an externality? Both of them are not economically viable today. Yeah, they're not.
Solar kind of is.
With a 30% tax credit, I'm redoing part of my house, and I'm going to spend $100,000 to put on solar cells on my house. I will be, yeah. Well, this is close to. I will be net close to net energy zero, and if I go buy an electric car, you know, and I put in all the electrical stuff for the electric cars. Okay. The wind farm. I've been working on some wind tower, some electrical transmission towers in Texas. Okay. Texas has lots of wind in West Texas, okay? There's not much else except desert there, okay? It's a lot of, but they got a lot of wind. And what happened in a lot of states, they've passed laws where they say that 15% of your electrical power must come from renewable resources by 2025. Well, in Massachusetts, that means we can buy from James Bay up in Canada where they have hydroelectric power, or we can put in a wind farm off of Cape Cod. And all the people in Martha's Vineyard are going to be whining, okay, because they don't want to see, huh? Well, you know, anyway. Actually, I was talking to a guy yesterday about, apparently there have been there's something called a ring vortex from these wind turbines, and planes will get caught in these. I mean, some of these things got 100-foot, 150-foot blades, and they're not going very fast, but they create a ring vortex. And some planes have been cut in two. They get caught in the turbine, and they can't get out of small planes. So I said, well, that'll solve the problem for the people in Martha's Vineyard. They can either have wind turbines or they can have visitors. Okay? Because a lot of people like to fly into the vineyard. Anyway, but in any case, American Electric Power is spending $1.2 billion in Texas, West Texas, to build electrical transmission lines to take the wind power to Dallas and Austin and other parts in East Texas where the people live, where it's not quite a desert. And no one has built the wind towers. This is a case, no one's going to build the wind tower until they have a way to get the power to the cities where people are going to use it. So American Electric Power, with some tax credits, I got to stop here, is going to essentially invest $1.2 billion to make it possible for other people to invest in wind turbines. Okay, those are some externalities. I got some more. We'll talk about them on Monday. Dr. Belmar will be here tomorrow. Okay, and there are some readings.